Again, it's a red stick.
What is going on, guys? Welcome back. In this video I'm going to show you how to use OpenSSL in the command line to do symmetric encryption. So we're going to take a file, for example a secret message or something, and we're going to use a password to encrypt that file to make it unreadable. Then later on we're going to be able to decrypt the file using the same password, which is what symmetric encryption is about. We have the same password for encryption and for decryption, which is different from asymmetric encryption, where we have a private key and a public key, one for the encryption, the other one for the decryption. So today we're going to talk about symmetric encryption, and we're going to do this with the Windows subsystem for Linux. You can do this on Linux natively. You can do this on Windows natively if you want to. I'm sure you can also do this on Mac, but we today are going to do it with the Windows subsystem for Linux. I don't think that there should be any differences. It's the same process because OpenSSL is platform independent. Now, if you want to check if you have OpenSSL installed, all you need to do is you need to say OpenSSL like that. If it opens a shell, you have OpenSSL installed. Otherwise, you don't have it installed. On Windows, you can do the same thing. You can open up CMD and you can just say OpenSSL. And if it opens the shell, you have it installed. Usually, you will have it installed if you have Git installed because Git comes with OpenSSL. Otherwise, Google is your friend. Just type OpenSSL installation Windows or Linux, whatever. If you don't have it on Linux, you basically just type sudo apt install OpenSSL, at least on Debian-based distributions, otherwise Pacman, DNF, and so on. And yeah, that's what we're going to do today. We're going to use not the shell, but a subcommand. So OpenSSL has a bunch of different commands that we can use. So for example, OpenSSL RSA or OpenSSL Gen RSA or OpenSSL CMS, for example. What we're going to use today is ENC, which I think stands for encryption. And if you want to see what ciphers we can use for the encryption today, we have to type OpenSSL enc-ciphers. And then you're going to see a bunch of different ciphers that we can use here. Now, maybe let me just make my camera a bit smaller and make this full screen. I think this should work, right? Yeah, so those are the different ciphers that we can use for the encryption here. Now, I don't know all of them. I'm not sure if anyone knows all of them, but what you want to use is the advanced encryption standard, and preferably you want to use something like 256 or, where is it? 128 CBC. There you go. This one or this one. Now, the other ones are not bad, but I think you should know why you use them, because I think that this is what is used most of the time. If you have a reason to use something else, of course use something else, but if you don't have a reason, I recommend sticking with this one. I think in a CTF for my university, I also used this one here. I'm not sure why we had to use this one, but if you don't know what to use this one. Otherwise, research and decide on which one you want to use. This is just a cipher, and the command is actually quite simple. Let's create, first of all, a message file. So message.txt, we're going to have here. This is, by the way, NeoVim, and NV is just my custom alias, because a lot of people ask in the comments always what NV is. NV is just NeoVim, my alias for NeoVim. The original command is NVim, just to make that clear. Hello world, this is a secret message. I hope you can only read this using a password. There you go. So now we have the message, cat message. There you go, this is the message. And now we want to encrypt that message. And in order to do that, we need to type the long OpenSSL command. Now, in order to not have my camera block this, I'm going to press enter a couple of times. What we want to do is we want to say OpenSSL enc, and now we want to specify a cipher. Again, the cipher that we specify needs to be from the list that I showed you, or that we saw using the ciphers command. And we're going to go with AES, Advanced Encryption Standard 256 CBC. This is going to be the cipher. I think CBC was block cipher or something. You can go to Wikipedia and see what CBC encryption is. Then we're going to specify a custom hex digest. So we're going to say MD, and we're going to specify SHA-512. This is basically for the key generation. Again, I'm not going to explain in today's video every mathematical detail of encryption. Encryption or cryptography in general is a quite quite mathematical and difficult field or complex field. So I'm not going to go into all the different parameters that we pass here. This is basically just specifying a hex digest for the generation of the key from the passphrase. And then we're going to specify a bunch of other things as well. First of all, we're going to specify PBKDF2, which stands for, I wrote it down here, password-based key derivation function 2. Again, if you're interested in what exactly is happening behind the scenes when we pass that, just Google and read through the papers, read through Wikipedia articles, or watch a tutorial. Essentially, what you need to know on a practical level is that this thing here makes our encryption more brute force resistant. And in combination with that, we also use the iter command, which specifies the amount of iterations that we do that. So we're going to do this that many times. We're going to do this now 10,000 times. Sorry. And we're going to also specify that we want to salt. Now, salting basically means adding to the hash input some random stuff. So for each new password, we generate a new salt, just a basic, we're salting this with a random with the random stuff, with the random input to get, more randomness through the hashing. And what we do then is we say -in message.txt -out message.enc, for example, for encrypted. Now we can specify a password. Let's go with neural 9 and verify failure. There you go. Come on. Neural 9, I'm too stupid to type a password. There you go. Now it works. And now we can go ahead and say cat message.enc. You can see here that this is basically unreadable. We can also try to open it in nvim, not message.enc. And you can see it's salted and we cannot really see anything here from the message. So what we can do now is we can remove the message.txt, we can delete it, and we can clear this. And all we have now is we have this message.enc file, which is the encrypted text. Now, if we want to decrypt that, we basically use the same command, but we add a -d tag. Now, we don't need everything of that command. So what we actually need is we only need to specify the hashing, we need to specify the cipher, we need to specify that we use this password-based key derivation, but we don't need to specify the iteration or the salt. So what we want to do now is we want to say again, OpenSSL, enc, and then we want to say AES 256 CBC MD SHA-512 password-based key derivation function 2. And we need to specify as in the message enc, as out. We're going to call this clear.txt, and now -d in the end. And we need to enter a password, neural9. There you go. Now let's see if we cat the clear text. There you go. Hello, this is a secret message. I hope you can only read this using a password. Now let's see what happens if I enter a wrong password. So if I type 12345, for example, we get a bad decrypt. So we see the digital envelope routines, decrypt final, bad decrypt, whatever. Basically, it didn't work. And I think we don't even have a file. Oh, we do have a file, clear.txt. Okay, it's decrypted, but it's not really what we were looking for. So didn't work. We only can decrypt this file with the correct password. So that's it for today's video. Hope you enjoyed and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.